In this video, we're looking at the power rule combined with the chain rule. Notice you have two different ways of denoting that here. Personally, I like the second one. We have the inside function g of x raised to the nth power. Power rule says we bring down the n to the front and copy the inside of the function and subtract 1 on the exponent. And then the chain rule says we also have to multiply by the derivative of the inner function. For example, looking at f here, notice that this is a composite function. We have 2x minus 5 on the inside, and then that function is being raised to the fourth power. So you can think of that as u to the fourth power from a previous video. F prime of x is, power rule tells us to bring down the 4. We're going to copy the inside and subtract 1 on the exponent. Now we have to remember to multiply by the derivative of the inside. Derivative of the inside is simply 2. So f prime is 8 times 2x minus 5 to the third power. In this example, we have a composite function again. Recognize that we can rewrite this if we want as 5x plus 1 to the 1/2 power. So the inner function is 5x plus 1. The outer function is u to the 1/2. G prime. Take the derivative of the outside. So we have 1/2, bring that exponent down, copy the inside, and then subtract 1 on the power. And then we have to remember to take the derivative of the inside of that first function, 5. Leaving us with 5/2, 5x plus 1 to the negative 1/2. And if we want to remove that negative exponent, we can do that. Just push that to the denominator and write it like this. If we wanted to take it a step further, we could even rewrite this using a radical. And we have g prime. In this example, we have the product rule and chain rule. F prime is, so product rule first, we have the first times the derivative of the second. So now we're taking the derivative of this second function. Here's where we need to use the chain rule. So power rule, bringing down the 6, subtracting 1 on the 6th power, and now multiply by the derivative of the inside. Chain rule. Derivative of x squared plus 2 is 2x. So that's the first part of the product rule. First times derivative of the second. Now we have plus the second. Copy that second function. And now we want to take the derivative of the first. So first thing we do is bring down the exponent, copy the inside, subtract 1 from the power. But notice that this is a composite function, so chain rule. We need to multiply by the derivative of the inside, which is 2x. From here, we'll go through and simplify. 12x times x squared plus 1 cubed times x squared plus 2 to the 5th plus 6x times x squared plus 2 to the 6th times x squared plus 1 squared. So we've taken the derivative, but from here we might be able to simplify a little bit, factoring this. Let's see, if they have a GCF, we have a 12, 6, and x, so we can pull out a 6x And then they have x squared plus 1 in common. And they actually have two of those factors in common. There's 3 in the first term, 2 in the second term. And then we also have x squared plus 2. There's 5 factors in the first term, 6 in the second term, so we have 5 in common. And now we have to see what's left over after we factor out the GCF. So we pulled out 6x from the first term. There's a 2 left over. We pulled out x squared plus 1 twice. There's 1 left over in the first term. We pulled out x squared plus 2 5 times, so we pulled that entirely out of the first term. Now looking at the second big term, we pulled out 6x, so that's done. X squared plus 2, we pulled out 5 of those. There's 1 left over. So we have x squared plus 2. And then x squared plus 1, we pulled out both of those. So we're good there. Now, simplifying a little bit more, inside those brackets, I'm just going to copy the first part for now. And inside the brackets, we can simplify and combine like terms. Here we get 2x squared plus x squared, that's 3x squared. Then we have a distributed 2 plus 2 is 4. And now we have fully factored f prime.